How many chances in life do you get to see 5 lightning-balanced engines running side by side? Probably just one. And that moment happened in Portland, Indiana. At the Tri-State Gas Engine Show, 4 owners brought 5 ultra-rare lightning-balanced engines, originally built by the Kansas City Hay Press Company in the early 1900s. Only 9 are known to exist today, and just 7 remain in working condition. Designed to power hay presses, these engines feature an unusual opposed 2-piston, single-cylinder layout. Instead of placing pistons in separate cylinders, both fire into the same combustion space, moving in perfect opposition, canceling out vibration. Each one weighs more than a ton, yet starts with nothing but muscle and magneto. Their rugged cast-iron frames, bolted to thick timbers, give them a commanding presence. You don't just notice them, you feel them. Setup began hours before the show opened. Each engine had to be securely mounted to prevent vibration from shaking it loose. Oilers were filled, governor linkages tested, belts aligned, and combustion chambers primed. Because there's no electric starter here, everything is manual. Hand cranking was the only way to build enough pressure and oil circulation for a clean start. That meant teamwork. One person turned the heavy flywheel a half turn, another followed. Spin, catch, spark. That's the rhythm. At the right moment, a magneto sends current to the igniter, delivering a hard thump that kicks the engine alive. Smoke puffs from the exhaust stack, the belt shudders, and the machine breathes. Each Lightning engine has a unique sound, but together they pulse like a mechanical drumline. Steady, deep, perfectly timed. It's mesmerizing to hear. The opposed piston setup also balances internal forces, earning these engines the nickname nickel-balanced. Even when running full tilt, they barely shake. You could place a coin on the head, and it might not even tip. Some mechanics even performed that trick, balancing a nickel while the engine fired, just to show off the engineering. Cooling is done the old-fashioned way, through open water tanks. No fans or radiators, just evaporation and circulation. It's primitive, but it works. Throughout the run, owners stayed close. They listened for changes in the exhaust note, watched for skips in ignition, and made throttle adjustments by ear. One engine showed signs of hesitation. The crew suspected uneven firing, likely from ignition drift. A small reset on the magneto fixed it, and the cycle smoothed out. Another had a slight belt misalignment. With just a few taps and a tug on the adjustment arm, it snapped back into true. Even while running smoothly, someone always had a hand on a wrench or a rag in their pocket. These engines demand constant attention. All around, you could feel the tension and pride. These engines weren't just machines, they were memories. And they were alive again. Spectators crowded around, some filming, others just watching. The smell of burning oil, the hum of compression, the occasional backfire, it pulled you into another era. This wasn't just a show, it was restoration in real time. These engines had spent decades in barns, forgotten, seized, rusted. Bringing them back took thousands of hours and endless mechanical know-how. I got no woes, no computers, no diagnostics, just hands, tools, and a deep understanding of combustion. Some onlookers pointed to the double rocker arms and asked how the valves worked. They don't. It's sleeve port timing. The pistons themselves uncover ports at the right moment, like a 2-stroke cycle, but more refined. Others marveled at the hit-and-miss governor. Rather than throttle back, it skips power strokes entirely to control speed. When load drops, the engine literally misses a beat. The vibrations underfoot weren't subtle. You didn't just hear the engine, you felt it. And as 5 of them rumbled side by side, it felt like the ground might lift. For many, this was the first, and likely only, time seeing so many working lightnings in one spot. Once the shutdown began, each flywheel spun slower, breaths shallowed, and the exhaust faded. Crowds lingered. Some asked questions, others just stood quietly, absorbing what they saw. And then came the stories. How rare parts were tracked down, how seized pistons were freed, how old manuals were followed like sacred texts. Some talked about childhoods spent near hayfields, where machines like these once thundered under the sun. On a quiet patch of oil-stained ground, a small group gathers. There are no spotlights, no cheering crowds, just the wind, the sound of tools against metal, and hands that have long known every bolt, every worn surface. This isn't a performance. It's a reunion. These machines, once marvels of engineering, have spent decades in silence, in sheds, in museums, or dismantled and forgotten. But today, 5 of them return to the light. 5 living relics. Each one tells a story. Each one carries the spirit of a time when power came from precision and machines were built to last. The people here don't speak much. They don't need to. Every motion is deliberate, every gesture rooted in memory. They've come not just to start engines, but to restart time, if only for a fleeting, unforgettable moment. What made it unforgettable wasn't just the sound or the motion. It was the effort, the care, the legacy brought to life. 5 machines, 1 gathering, a moment that may never come again. How do you wake up an engine that hasn't run in decades? This Duvant 9 VOS, an old diesel workhorse, was pulled from storage and brought back to life. Before ignition, the team flushed the fuel system, checked compression, and reprimed the injector. With a spin, a pop, and a puff, it ran. Moments like this aren't just mechanical. They're magic. Bring a machine back to life after more than 40 years of silence. This is the story of a Deutz MAH 711 stationary engine, built in 1940, 553 cc, 6 horsepower at 1,500 revolutions per minute, that hadn't fired up since the disco era. Buried behind an old threshing machine and forgotten under hay, it spent decades in a barn, then the last 5 years under a tarp in a damp shed. Until now. Reviving it began with the basics, removing rusted valves, cleaning out fuel lines, disassembling the injector nozzle, and making sure the pump could breathe again. After light re-oiling and a few test pulls, it was time. No electric start, just a fuse, a flywheel, and some crossed fingers. You hold your breath, pull once more, and hope the past remembers how to move. And then, that first deep cough. The kind of raw mechanical growl that sends chills down your spine, a puff of smoke, a louder rhythm, and finally, yes, it roared. Everything wasn't perfect. The valves were stiff, the pump had corrosion, and the injector looked like a rusted bullet. But somehow, it all came back, piece by piece, with patience and bare hands. Moments like these aren't about perfection. They're about revival. about bringing something old and stubborn back to life and hearing it speak again. Each sound of metal, each puff of smoke, was more than just mechanics. It was a reply, as if the machine, after a long silence, was slowly remembering how to speak. Hesitant at first, but growing stronger, more confident with every turn. This wasn't a professional restoration. This was one person, one engine, one moment. What does it take to wake a Bristol Hercules 216 after 25 years of silence? This 14-cylinder radial engine, once powering World War II bombers, had been dormant for decades. After months of preparation, checking oil circulation, flushing the fuel system, and inspecting ignition components, it was finally time. A powerful electric starter spun the propeller, slowly at first, then faster, until combustion took over. A sputter, a deep rumble, and then it burst into life, barking out thick smoke and echoing like thunder. This wasn't just an engine test. It was a resurrection of sound, power, and history. It started with nothing but a bare engine block. What followed was a full resurrection of the legendary NTA 855, and we caught it all. This NTA 855, a 14-liter turbocharged inline-six, sits at the heart of heavy-duty trucks and industrial generators. After a complete teardown, this monster was reborn, and you're about to hear every detail. The process began at the stripped-down block stage. First, every component was carefully organized. Cylinders were inspected. Liners were checked for scoring. Cummins techs recommend using wet liners for faster heat dissipation and easier replacement without reboring the block. Off came the pistons, rods, and crankshaft. Each rod bearing setup was cleaned and measured. Thrust and crank bearings underwent thickness checks per the official workshop manual, which emphasizes proper lubrication priming before any rotation. Next came the block prep. Cleaned, degreased, and pressure tested. Coolant galleries and oil passages were flushed, ensuring no debris remained. Then the liner installation. Liners soaked in coolant, torqued to spec, and sealed. Valves were inspected, seats cut, guides replaced. Cummins workshop notes call for blade cleaning valves and verifying proper seat contact. Meanwhile, the camshaft and followers were checked for wear, new bushings pressed where needed. You could feel the story building with every reassembled part, like watching a skeleton grow muscle and breath again. Assembly began with the crankshaft, installed, torqued to spec in the main journals. Once secure, rods and pistons went back in, rings correctly gapped per the manual. Every torque spec, dowel, and alignment pin double-checked. Next came camshaft timing, gear train meshed, injector pump timed with cam, and magnetos prepped. No flashy paint job. No shortcuts, just raw hands-on precision from people who respect the machine. After block assembly, the head went on. Overhead fuel system checked, Cummins PT injectors, valves, and injector lines set evenly. Turbocharger was installed with new seals and alignment marks. Then came external systems. Oil sump, filters, water pump, and accessory drives reattached. Gear train properly torqued to eliminate thrust loads. Priming was crucial. Operators used shop air and oil pump to pressurize lubrication circuits to a minimum of 30 psi before crankshaft spinover. Complies with Cummins manual pre-starting procedures. Fuel system bled. Priming pumps cranked until clean diesel flowed. This is the part where hope meets tension. when all the prep either pays off or falls flat. Now came the moment of truth. With safety in place, they engaged the starter, a powerful 24-volt electric system. The engine spun over smoothly, oil pressure climbed, then suddenly, combustion kicked in. The first deep diesel thump echoed, the sound of a rebuilt legend. Timing was adjusted, compression and glow plug heat cycles checked. Black smoke cleared, then the engine settled into a smooth idle. There's nothing like hearing that first roar after silence. It's a sound that hits you in the chest. Ground checks followed. Sensors observed. Oil temperature and pressure traced. Coolant flow watched. Vibrations were minimal thanks to precision balancing and properly torqued flywheels. Not a hint of knock or excess noise. After stabilization, they increased RPM slowly, listening for throttle response, turbo spool, and any surge. It passed with flying colors. After weeks of methodical work, it fired up like it never aged a day. Finally, a dyno test. The NTA 855 produced solid torque and the characteristic Cummins rumble. Exhaust readings were clean. No leaks, no smoke, just efficient diesel power. The rebuild wasn't driven by aesthetics. It was about bringing an engine whose life had nearly ended back to full strength. Moments like this didn't just rebuild a machine, they honored decades of engineering legacy. Every sealed liner, torqued bolt, and magneto adjustment carried history. If you've ever wondered how these industrial beasts are kept alive, this was the story: hands-on, old school, and beautifully technical. Because in the end, it's not just about getting the engine to run again, it's about how it runs. No electronic controls, no automatic sensors stepping in, just fuel, air, steel, and pure mechanical precision. It's the kind of power you don't just measure in horsepower, you feel it in your chest and you respect it. Those heavy sounds, those primal vibrations, are a reminder. Mechanical engineering, though pushed into the past, still lives on for those who know how to listen. And with every start, it doesn't just ignite the combustion chamber. It reignites memory. A memory of a time when an engine didn't have to be smart to be great. How do you wake a Soviet-era 1,000 horsepower radial engine after years of silence? This 9-cylinder, 30-liter Shvetsov Ash 62 roared back with a blast of smoke and thunder. When that first cough turned into a full-throated roar, it felt like history breathing again. It's not every day you see a World War-era radial engine fired up on a Volkswagen chassis. This 9-cylinder beast, originally built for tanks and now running on propane, comes alive with flames and fury. The team checks ignition timing, fuel delivery, and oil pressure before spinning it over. When it roars to life, shaking, smoking, and snarling, its raw mechanical power on full display. Watch this vintage Lindwood front-engine dragster awaken, with weed burners spitting fire and the air filled with methanol fumes. The team starts it on methanol for smoother ignition, then switches to nitro for raw, explosive power. Every step is hands-on, spark timing dialed in, Fuel lines purged, throttle linkages checked. Once nitro hits the system, the tone shifts, louder, angrier, alive. Flames shoot from the side pipes, engine note climbing into a furious snarl. It's not just a startup, it's a full-blown mechanical tantrum from drag racing's golden age.